welcome to lesson 13, the final lesson in our geology and coasts playlist. This is all about a place called Holdernesse. Please write the title and copy the keywords. The keywords are just a recap of the coastal management strategies, two of them that we looked at in the previous lesson. Pause the video now and answer the questions. Please now check and correct your answers. Let's understand where Holdernesse is. So we're looking from space at the United Kingdom. To the west of the UK, to the west of Ireland, we have. Let's understand where Holdernesse is. So we're looking from space at the United Kingdom. To the west of the UK, to the west of Ireland, we have the vast expanse of the Atlantic Ocean. But to the east of the UK, we have the North Sea, which is still a large body of water. This means that the fetch, remember that word fetch, which is the distance over which the waves and the wind travel. The fetch is large or long. But we're now going to zoom in and find out about the Holdernesse coastline. So we're going to go to the northeast or east coast of the UK, or it's certainly the northeast coast of England, and it's near this large city called Hull, which is in Yorkshire. Okay, the Holdernesse coastline is this strange shaped coastline. It's about 60 miles long from north to south. At the northern end, we have this area which is called Flamborough Head, which is a headland. The rock here is made out of chalk, which yet is a soft sedimentary rock, but compared to the rock that stretches south of Flamborough, it's more resistant. Now, to the south of Flamborough Head, this is the Holdernesse coastline, Hornsea, Withensea, and this area is made from an incredibly soft type of rock called boulder clay. And this rock was left behind when the glaciers retreated and melted 10,000 years ago. And it's an incredibly soft rock, not ideal for building houses, but we've managed to do it nonetheless. So first off, the rock, the geology of the area is that it is incredibly soft. So that makes it erode quickly. But also, what is important here is that the prevailing wind from across the North Sea comes from a northeast direction. So this means that we get waves coming in at a very acute angle all the way along this coastline. So this means that as well as there being high rates of erosion, we have a really fast rate of longshore drift, of transportation. And the sediment gets transported from the north southwards. Eventually, that sediment reaches the end of the Holdernesse coastline. And we arrive at a sand spit, which is probably the best example in the country of a sand spit. It stretches out across the estuary of this river, which is the Humber River. And it's quite large in size, and you can see how the end of it has got curved by the prevailing wind. So as the sand has been transported north to south, eventually it's been deposited out across the estuary. Behind the spit, we have a salt marsh, and you can see the murky, dark water. That is the sediment that has been deposited by the river as the river has flowed out to sea here. So the last thing I'm going to say before we start looking at some coastal defences in this area is, again, it's about the factors that cause erosion on this coastline. So in addition to the waves coming in at an angle, because the fetch, the distance over which the wind and waves travel, is so large, the types of waves that pound this coastline are destructive waves, where the swash crashes down vertically onto the beach and then pulls the beach or the parts of the cliff away back out to sea. What is interesting about this coastline, as well as the physical factors, are the human factors here. Now, hopefully you'll be able to recognise how land is used for much of this. All these green rectangular shapes represent farmland. But actually there's also some settlements along here. They're not large cities, but they are areas of residential houses. If you look really carefully along this stretch at Hornsea, if you zoom right in, you can see coastal defences. Can you remember from the previous lesson what coastal defences these are? These vertical lines of rock, or these vertical walls stretching out to sea. That's right, they're called groins, and you can see quite clearly they've trapped sediment, they've trapped sand that has been washed along the coast, has been transported along the coast. And what's happened as a result is it's built up the beach so that the waves break further out. If you look really carefully there, you can see the waves have broken a lot further out, and therefore the coastline here is protected. In addition to that, you can see another type of coastal defence, another type of coastal management here. We can also see an example of that slightly further along. So if we zoom in here, you should be able to see that second coastal defence. The large stones, giant stones placed along the coast. That there is your riprap, which is the line of large stones which absorb the wave's energy. You can also see along here where you have houses behind that you've even got a sea wall. So this is a great example where you can see groins, you can see a sea wall, you can also see riprap. Next thing we need to look at, and then we're going to do some questions on this. Next thing to think about is what happens when you stop protecting the coastline. So here, this area has 3 different types of coastal defence, and if you look to the left of the picture, you can see why they've decided to protect this area. As you go further south, here's just riprap, and then suddenly the riprap stops and there are no groins. Look at what's happened to the erosion. It's actually increased south of the groins and the riprap. You ask yourself, why is that? Why has this area been allowed to fail and been allowed to erode naturally? Well, it turns out that this area is just a holiday park. It's some caravans, and it's clearly the people that are in charge of managing this coastline. They've decided that a caravan park is not as valuable economically as this large residential area. So the poor people that manage this holiday park have had to allow their land to fall into the sea. Okay, pause the video and do a quick quiz on the Google Earth tour. Go back in the video if you need to watch any of it again. Here are your answers. Please check and correct. Okay, what we're going to do now is we're going to do a series of questions that test your understanding of what and where this Holdernesse coastline is and the physical factors. So what I'd like you to do using that figure is to describe the location. Please note that this question is a 3-mark question, and so it is expecting you to use the information provided in the figure. You don't need to explain anything because it is a describe question, so you need 3 facts, and it can be in bullet points. Here are the answers. You needed to say something about the northeast southwest, your compass point. So we said it's on the east coast, it's even the northeast coast of England. Remember that from here you get Scotland. So it's the northeast of England, but the UK as a whole, from there to there, I think you'd probably say it was the east of the UK. Second point, We wanted to say how big it is, so we say something like it stretches for about 60 miles. How do I know that? Because I used the scale line provided. Then we want to have the name of something, so I've said you could say from Flamborough Head, which was up here in the north, to the Humber Estuary down here. There's our third mark. Anything similar to that will be fine as well. Okay, the next one, I'm going to give you 4 minutes to do this. It says using figure 1, but you know you can use your understanding of this area as well, if you remember the Google flyover that I just did. Give yourself 4 minutes, and I want you to explain how two physical processes. So what we're looking for is a point and then a develop. So 1 point to state something, and then the development will be to develop that point, and then we're going to choose another point develop as well. Pause the video now. Answers. You could have said that prevailing wind comes in at an angle. There's your point, tick. And because it comes in at an angle, longshore drift transports sand south. Or we could have actually said longshore drift was rapid. You could have also said that the fetch is long across the ocean. The fetch is long. That's your point. So therefore waves can be destructive, using your own knowledge there. You could have also said that boulder clay, which is, look at the map, it even tells you that it's on there, boulder clay, is a soft rock which is less resistant to erosion. Just remember that the question was asking you about the rapid rate of erosion. Please green pen your answer and give yourself a mark out of 4. Right, for this one, this is a bit different. I'm going to talk you through a type of mass movement that I mentioned briefly in the Google video. Just watch this. What you can see in the video there is slumping. Now this is not a rockfall, this is not a landslide. This is what happens in this particular area. Because the rock, which you can see here, is so crumbly, and it can fill up with water very quickly, so it's a porous rock, which means it soaks up water like a sponge. What happens is over time the soil and the rock gets saturated with water. Eventually it gives way, and you have these fractures, these kind of fault lines in the rock where suddenly the rock gives way, and you have this process of slumping. There's no rock falls, there's nothing dramatic like that. Instead, you get these kind of curved shapes like this, where the land simply gives way. What I'd like you to do now is to try this question. Note how it says using a named example. I've already named it for you. You don't actually get any marks for naming it, but what they say is you will be capped at 1 mark, or if it's a 4-mark question, they'll cap you at 2 if you don't mention it. So I want you to pause the video now and see if you can answer this. Explain how mass movement. So we're going to have to name it and explain it in the form of a point develop. Pause now, give it a go. So we're going to get 1 mark for saying slumping, tick. Then we needed to develop the point. All we needed to say is the rock. Maybe we could have actually mentioned the rock. That would have been an improvement on the model answer. This is when boulder clay gets saturated with water and slips down the cliff. So there's a lot for us to cover in this lesson, but it's a good thing because we can build up a really detailed case study of the area, and that will help for our memory recall at a later date. What I'd like you to do now is to copy that sketch map showing the Holdernesse area. And then I'd also like you to write somewhere, I'd like you to write terminal groin syndrome. Once you've done that and you've got your map ready, I would like you to watch 2 clips that are in the description below this video. They both talk about coastal management, but they also talk about the conflict between areas of high value land and areas of low value land, and how some people have their land protected while others don't. Please watch those 2 clips, then return to this. Okay, so what we're going to do is we're going to mark up this map and build ourselves a really detailed base map of the area. So first thing we can add here is that we've got a headland at the top. And this was made from chalk. Then this whole area here, stretching south, was made from boulder clay. Now if we remember, the prevailing wind came in from a northeast direction, so we're going to write prevailing wind. And if we also remember, the waves and the wind travel over a very long distance, so it was a long fetch. Now, because the prevailing wind comes in at an angle, we also had a fast rate of transportation. So we had longshore drift. If you remember, the longshore drift was this zigzag motion as sediment gets transported along the coast. So the next thing is that we can think about the different types of coastal management. So if you remember, one way that we manage the coast is by building a groin, and they stick out to sea. But if you remember in the video that you just watched, what happens is sediment will accumulate behind the groin in this kind of strange shape. This builds up the beach and it protects the coastline along here, because what you find is that the waves are crashing out there instead of right up by the beach. But here's the problem, and you saw this in the video that you watched in the description. Terminal groin syndrome. Terminal means the last. Groin is the wooden fence or line of stones sticking out into the sea. Syndrome is the problem. So what happens, watch what happens carefully after this last groin here, this one. What you find is this whole area to the south of the groin, this area suddenly finds itself without this sand. Now previously the natural process of longshore drift would have pushed and transported the sand southward. And so what actually happens is this area gets nothing, it gets no sand. So the waves start breaking here and here. And what you actually find is that the coastline erodes even more than it would normally. So here's, this is why it's so unfair. If you live here, your house is going to be protected. But if you live on a farm, like the couple in the video, Hill House Farm, if you live there, your land is going to be eroded even faster. So coastal management creates winners and losers. Okay? Please make sure your base map looks something like that. Let's just add one further detail. We're going to have high rate of erosion. Add that on there. And then up here we can have lower rate or speed of erosion. Have a go at this question. It's a 3-mark explain, for which we need to do a point, develop, double develop. Please use the map and look carefully at what's happened here and here. Pause the video now. Answers. Hopefully you should have recognized that there was a groin here. Tick. This has prevented sediment from being transported. Tick. Or you could have said that it's just that it's reduced erosion. Tick. And then the double development means that the coastline here has been protected. All those houses have been protected. There's the double development. Next, study this satellite photo carefully. Pause the video and give yourself 2 minutes to explain one reason why this area has not been managed. So what clues are there in here that this area has not been managed? Why is this area not being managed? Pause now. Answer. You can see, first off, that the sea has been eroding the cliffs next to farmland. But why have they not managed this area? Because the farmland is not valuable. Or if you'd said anything similar to that. Please pause the video, give yourself 3 minutes. As this first one is a state question, it doesn't need to be a sentence. Then for the next question, again, using figure 4, suggest one reason why this coastal management strategy, i.e. what you said there, why has it been used? Look carefully at what you can see there. For this question, do yourself a point, develop. Answers. So we'll do this one first. The one reason is that here you can see in this area there is a gas terminal, or you could just say industry. It's clearly not houses. There's your point. What you needed to say is that it's valuable to the economy. The type of coastal management strategy was riprap or rock armour, which you can see there. Pause the video. A, B, C or D. Answer was slumping. And you can see clearly from this satellite photo how large chunks of boulder clay have slumped or collapsed into the sea. So this final question is more difficult. I'm going to give you 4 minutes to do this. What we're going to look for is 2 impacts of the coastal management strategy shown. Now the coastal management strategy, you've got to look for it. Now you could argue that here there's a coastal management strategy. This looks like farmland here. The coastal strategy here is managed retreat or do nothing. That is kind of a strategy. But actually we could have looked at the riprap, or we could have looked at the groin. So you're going to get 1 mark for identifying the coastal management strategy, and then you're going to get the 2nd mark for explaining what it did. So you know what, how it worked would be fine for that. And what is it meant for this area of land? And for the 2nd one, what is it meant for this area of land? Pause the video now. Answers. So we identified that there was a groin has been built to protect the residential area, or you could have said there was a riprap. This means that the houses have been protected, or you could have said the beach is bigger, so there's less erosion. Anything around that would have been fine. The next one is you can talk about this thing we talked about earlier, the terminal groin syndrome. These groins here have stopped the sediment from traveling down here. So as a result, there's increased erosion here. Give yourself a mark out of 4 and green pen it. So this is an optional challenge question. This lesson is a big deal. It's longer than the others, but it's important that we build up a detailed profile of our case study. What I'd like you to do, please, is to write, evaluate the effectiveness of the coastal management strategies shown. Now, this word evaluate means to measure. Just as assess does, it means to measure, but then finally, in our conclusion, we come to a decision. It says coastal management strategy, so in a moment I'm going to show you the figure 1, and we're going to have to find those coastal management strategies. And that word effectiveness is important, because that word effectiveness means, was it any good? Did it work well? So we need to find the coastal management strategies and then ask ourselves, did it work well? Okay, so this is figure 1, coastal management at Holdernesse. There's a lot going on in this resource, but it's a really good one. So at the top of this resource, you can see 2 maps at the top left and top right. The 2 maps showing the Holdernesse coast. In the middle at the top, you have a graph that is showing the annual rates of erosion, and it is measured in meters. Then we've got 3 locations, A, B, and C. And then at the very bottom we've got 3 photos, A, B, and C. So whatever's happening in A, you need to look up here and ask yourself, what are the rates of erosion? If this strategy in A is effective, then the rate of erosion won't be that much. Then we look at B, what is going on at B? Take your eyes up to this map here and look at the rate of erosion, and it's pretty much 0. Then lastly, look at area C. Look up at the erosion map and find out what the rate of erosion is. So is it effective, the coastal management strategy? What I'd like you to do is to do an AKU, and conclusion piece of writing using this resource. Please remember to use the figure. So I want to see numbers, I want to see the names of locations, and I want to see the names of management strategies. And then in the conclusion, you need to ask yourself, overall, were these coastal management strategies effective at stopping erosion and protecting areas of land? Give it a go and send me your answers. Lastly, a quiz to consolidate the learning in this lesson. Please write your answers, pause the video. Please check and correct your answers. Well done, we've got to the end of a big lesson. That was pretty much a double lesson on the Holdernesse coastline. We're now going to move on to the second part of section A, which is all about rivers. So you can see at the top right of the screen here, we have 8 lessons all about river processes. I look forward to seeing your work on that. Thank you.